Hey, everybody. So, we've specifically been talking about the different types of monoamines and the drugs that affect them. Now, we're going to talk very generally about the different types of drugs that affect the release of monoamines. So, as I've kind of talked about before, there are some drugs that work by blocking the storage of neurotransmitters into vesicles. So, in this particular case, the neurotransmitters, because they're not being stored in vesicles, they basically get metabolized by enzymes inside the neuron, and they're never going to be able to be released. So if a drug blocks monoamines from being stored into vesicles, it's going to be an antagonist because it inhibits the actions of monoamines. So reserpine is an antagonist. It is used to treat snake bite, and the reason that you'd want to treat snake bite, it obviously can result in high blood pressure that can be really dangerous. So by blocking the actions of neurotransmitters like norepinephrine, reserpine can actually stabilize blood pressure. And because of that, it's also been used to treat hypertension. It's been used to treat psychosis. And those are kind of effects related to dopamine and serotonin. Now, one of the things that's kind of interesting, because serotonin and norepinephrine are reduced, the side effects that you will typically tend to see include tranquility and depression. We will come back to the fact that it produces depression later on in the semester when we talk about the development of antidepressants. So now we're going to talk about another type of neurotransmitter. We're going to talk about peptides. In particular, endorphins, our body's natural painkillers, have a peptide structure. So in particular, peptides are chains of amino acids. Some of them will act as neurotransmitters. There are many different types of peptides that act as neurotransmitters, but we're going to focus on opioids. So endogenous opioids are called endorphins, and we call them endogenous because we produce those in our bodies. They're produced by neurons that are located generally in the hypothalamus. The receptors that bind these are called opioid receptors because they're named for their affinity for opium produced by the poppy plant. Opioid receptors are located all throughout the central nervous system. They are all metabotropic, so they're very slow acting. Some will produce EPSPs, others will produce IPSPs. So opiates or opioids are one of the neurotransmitters that can actually have both excitatory and inhibitory effects. And remember that whether something is excitatory or inhibitory depends on what ion channels are opened. If it opens something like sodium, it's going to be excitatory. If it opens something like a chloride receptor or a potassium receptor, it's probably going to be inhibitory. There is no reuptake mechanism for peptides. So let's start by talking about drugs that actually affect opioid receptors, and we'll talk about these in more detail very soon. The drugs that affect these include synthetic opioids or semi-synthetic opioids. That includes things like fentanyl, oxycodone, and heroin, as well as natural opiates like opium. All of these function as agonists. They enhance the effects of endorphins, and we'll talk more about this soon. But now we're going to move on to drug abuse. So this is this is something that's starting to become more and more common. I actually just read this morning that compared to other states, Missouri is still seeing a rise in deaths by drug overdose. Many of those are going to be related to use of opioids because they are often used and abused as painkillers. So let's get into some basic definitions about drug abuse and addiction. So, drug abuse is a relationship with a drug that typically will lead to adverse consequences. The abuse potential of a drug depends on many different things, like the route of administration that you take. So, whether you take it orally or you inject it into a vein, the amount you use, the context of use, like some environments actually increase the potential for abuse. The pharmacology or the mode of action of the drug. So, what this tells us is that drug abuse is a multifaceted issue. It is a multifaceted thing. And we typically consider drug addiction a psychological disorder. Because of that, some components of drug abuse, like tolerance, though, are associated with biological changes. Now, tolerance is basically when you find that you need to take more of a drug to have the desired effect. The body basically gets used to you taking the drug and it loses some of its effect. The actual biological mechanism is pretty complicated. There are two different things that happen. Generally, the more that you take of a drug, the better your body becomes at breaking it down. The liver will actually increase its metabolic activity. It'll make more of the enzyme that breaks down whatever the drug is. Doesn't matter if it's caffeine, nicotine, alcohol, or Prozac. You become better at eliminating it, so you become less sensitive to it. So that's the metabolic factor. The neurochemical factor is that the neurons may become less sensitive to the drug. They may actually reduce or downregulate the number of the receptors that they have. Generally, tolerance comes on with regular use, and it can actually decrease or reset with a period of non-use. Many of you probably have a pretty fond relationship with caffeine. So typically what you will find is that you probably have some tolerance level. And if you stop caffeine consumption for a few days or a few weeks, and then you have caffeine after that break, you're going to feel a much bigger effect from it. And then finally, we have withdrawal. These are symptoms that you will experience when drug use decreases. So let's talk about caffeine again. Let's say if you don't have coffee one day, you might have some withdrawal symptoms. Generally, withdrawal is going to typically be the opposite of the effects of the drug. Caffeine is a bit of a stimulant. It affects sleep-wake behavior. So it is also a vasoconstrictor. So what you will typically tend to find is you might have a headache because of vasodilation. You might feel pretty tired and sluggish. Symptoms of tolerance and withdrawal are going to differ for different drugs. Some of those are relatively innocuous. On the other hand, alcohol and opioid withdrawal can actually be pretty dangerous. A few other things that we need to talk about are dependence. So physical dependence is when you habituate to the drugs. So things like tolerance and withdrawal are aspects related to physical dependence. Drugs like alcohol and opioids have really strong physical dependencies. In contrast, a psychological dependence are the mental symptoms of attachment to the drug that may include drug craving, that can include anxiety or irritability in absence of the drug. You can actually have a psychological dependence without a physical dependence. So, for example, something like marijuana that doesn't really have a strong physical dependence may actually have a strong psychological dependence. Many people will say that marijuana is not addictive because it doesn't have strong withdrawal symptoms, but addiction isn't just about physical dependence. There are people who use cannabis and they're probably using way too much because of that psychological dependence. Now, another example is somebody with a chronic pain condition. They're taking OxyContin. This person may have a physical dependence, but they may not have a psychological dependence. Interestingly enough, craving is believed to be changed by changes in the mesolimbic pathway. So that can actually, changes in the brain's neurochemistry can actually lead to the psychological effects. So, one of the things that we have to talk about are the routes of administration. Generally speaking, the faster the route of the administration, the faster the drug is going to work, and the more addictive potential it likely has. So, these are some of the different ways that you can take a drug. In general, if you take something by the oral or digestive route, it's going to take about 20 to 30 minutes before it actually has a significant impact on brain function. Generally, if you want to get something into the body quickly, you are not going to be giving them a pill. Additionally, the drug has to be strong enough to be broken down by digestive enzymes in the stomach, in the liver, and in the gut. The next type is intraoral. This is through the blood vessels in your mouth. So you may actually be aware that when you drink coffee, it doesn't take you 20 minutes to feel the effect, even though it is an oral administration. Part of that's due to the fact that you have a lot of blood vessels in your cheeks and under your tongue, and they can absorb those chemicals. So coffee starts to perk you up pretty quickly because of that. The next route of administration is insufflation or intranasal. This is when a drug is applied to the nasal mucosa. This is a membrane with lots of blood vessels. Insufflation is just jargon for snorting. The drug gets stuck in the nasal mucosa, it's absorbed through the blood vessels, and it goes to the brain. And it takes about 3 minutes to do that. We have transdermal or topical. This is used very rarely. Sometimes we'll use it for suppositories to Transdermal is pretty common for patch medications. Some forms of birth control or nicotine are applied. The idea with the patch is that it's absorbed very slowly over a long period of time, so it takes minutes to hours to actually reach the brain. Skin is a pretty robust barrier to absorption, but it's not impermeable. And then finally, we have inhalation through the lungs. That's smoking. A substance is burned, converted into vapor, which can be inhaled as a gas. It's burning active components like tobacco or cannabis. Some of that will be destroyed, but some will get in. One of the key features of inhalation is that it's very fast acting. In general, it takes about 7 seconds in smoking to get nicotine to the brain. That's actually a little bit faster than how injected heroin reaches the brain. So substances will be absorbed into the lungs, and then they will travel from the lungs to the heart and from the heart to the brain. And this happens very, very quickly. Another route of administration is IV. So obviously this is something that is going to take 10 seconds or more. If you inject a drug into the carotid artery, it gets to the brain in half a second, but that's pretty dangerous. There's a lot of pressure there. So most people will inject in veins in the arm or leg. The time it takes to get to the brain depends on the injection site. IV is fast. But you can get a higher dose of administration through injection. We have intramuscular injection. This is something that's injected into the muscle mass. It generally will take longer to get to the blood and to the brain. This is actually a pretty common mode of administration for insulin if you're diabetic. Intraperitoneal injection. This is not commonly used in humans, but it's pretty commonly used in lab animals. It's difficult to get in by IV because animal veins are small. So we inject it into the abdominal cavity where there's a lot of blood vessels, and that takes about 3 minutes. Finally, we have a subcutaneous injection. This is done under the skin. It's a very slow and steady absorption. Diabetics may get insulin this way. If you've had a tuberculosis test, this is also subcutaneous. Okay. So drugs of abuse are based on potential factors. So first of all, pharmacology. Some drugs act preferentially on parts of the brain that are associated with craving, like methamphetamines. They require fewer administrations to make somebody addicted compared to something like nicotine. The route of administration plays a strong role. Generally, the faster it takes to feel the effect of the drug, the more addictive potential it has. The dose dose matters. The more you take, the higher the risk of addiction. And then finally, the psychological context. If you're using it to cope with stress, that's going to increase the risk of developing a very long-term relationship with the drug.